Earth from space. The hidden planet we never see from the ground. From the ground, Earth can feel almost endless. The horizon surrounds us. Mountains appear permanent. Oceans seem impossibly large. Cities feel bright enough to dominate the night. But from space, everything changes. The largest mountain ranges become wrinkles. Hurricanes become spirals. National borders disappear completely. And the entire atmosphere, the only barrier separating every human being from the vacuum of space, looks like a thin blue line wrapped around the planet. Yet this familiar image hides something extraordinary. Earth is not simply a blue sphere covered by white clouds. Seen from orbit, it behaves like a living machine. It glows in the dark. Its oceans reveal waves hidden hundreds of feet below the surface. Deserts feed forests on the opposite side of the world. Islands write enormous spirals into the clouds. Plants change the chemistry of the atmosphere with the seasons. Even the colors we associate with Earth are more complicated than they appear. So today, we are not simply looking down at our planet. We are going to examine the hidden Earth, phenomena visible from space that most people never notice, and stories that ordinary photographs rarely explain. The atmosphere is almost invisibly thin. In photographs from orbit, Earth's atmosphere often appears as a narrow blue arc along the horizon. It looks delicate because it truly is. Approximately 80% of the atmosphere's mass is contained within the troposphere, the lowest atmospheric layer. On average, this layer extends only about 12 kilometers above the surface. Compared with Earth's diameter of more than 12,700 kilometers, the breathable portion of the atmosphere is astonishingly thin. Imagine a large apple. The atmosphere that supports almost all weather and terrestrial life would be proportionally thinner than the apple's skin. There is also no solid wall where the atmosphere suddenly ends and space begins. Instead, the air gradually becomes thinner until individual particles can travel enormous distances without colliding. What looks like a sharp border in space photographs is partly an optical illusion. When we look sideways through the edge of the atmosphere, our line of sight passes through a much greater amount of air than when we look straight down. That long path concentrates scattered sunlight into the brilliant blue rim seen by astronauts. The atmosphere may appear like a protective shell. In reality, it is closer to a fading mist. Earth glows even where there are no city lights. The dark side of Earth is not completely dark. High above the surface, the atmosphere produces a permanent, extremely faint glow known as airglow. Airglow can appear green, red, orange, yellow, or even purple. It is created when atoms and molecules in the upper atmosphere absorb energy from sunlight. Later, as those particles release that energy or recombine with electrons, they emit photons. This process is similar, in principle, to the chemical reactions inside a glow stick. Unlike the aurora, which becomes intense during interactions between charged solar particles and Earth's magnetic environment, airglow occurs across the planet almost continuously. From the ground, it is difficult to see because it is faint and easily overwhelmed by artificial light. From orbit, however, long exposure cameras can reveal luminous bands wrapped around the planet. The glow is not always smooth. Atmospheric gravity waves can create ripples, bands, and enormous wave patterns within it. These waves can begin when wind passes over mountains or when powerful thunderstorms, hurricanes, and tornadoes disturb the atmosphere. Some of that energy travels upward, reaching the boundary between the atmosphere and near-Earth space. This means that a storm occurring near the surface can create wave patterns visible hundreds of kilometers above it. Earth's upper atmosphere is not a quiet ceiling. It is an illuminated record of events happening far below. Sunglint reveals another ocean. In many satellite images, part of the ocean appears covered by a blinding silver reflection. This is called sunglint. It occurs when sunlight reflects from the water at exactly the right angle toward a satellite or astronaut. For scientists measuring ocean color, sunglint can be an obstacle because it hides the true color of the water. But under the right conditions, it becomes a powerful scientific tool. The reflected light exaggerates tiny differences in the roughness of the sea surface. As a result, features that would normally remain invisible suddenly appear as bright and dark lines. These can include current boundaries, eddies, ship wakes, oil films, freshwater layers, and enormous internal waves. Internal waves do not primarily travel along the top of the sea. They move between layers of water with different temperatures and densities. Some occur roughly 100 meters below the surface, but still alter the texture of the water above them. In satellite images, they can appear as long, curved bands, extending for tens or even hundreds of kilometers. From the ground, the ocean surface may look calm. From orbit, reflected sunlight can expose a hidden landscape of moving water beneath it. Sunglint is therefore more than a beautiful reflection. It is a temporary window into an ocean we normally cannot see. Islands can draw giant spirals in the sky. Some of Earth's most elegant cloud patterns are created by small islands. When steady wind encounters a tall, isolated mountain or volcanic island, the air is forced around the obstacle. Under certain atmospheric conditions, alternating vortices form behind it. These are known as von Karman vortex streets. From space, they resemble a line of enormous spirals, curling in opposite directions and stretching far across the ocean. The same basic fluid behavior can occur behind a bridge pillar in water, behind an aircraft wing, or behind almost any object placed in a moving fluid. But from orbit, an entire island becomes the obstacle, and clouds make the otherwise invisible airflow visible. Cloud streets can also form as rows of long, parallel clouds when cold air passes over relatively warmer water. The result can look carefully designed, as though someone has combed the atmosphere into perfect lines and spirals. But no artist created them. They are the visible handwriting of moving air. The ocean sometimes turns milky turquoise. Some of the brightest colors seen in Earth's oceans are created by organisms too small to see individually. Coccolithophores are microscopic, plant-like organisms that live near the ocean's surface. Each cell is covered with tiny plates made of calcium carbonate. When trillions of these organisms gather during a bloom, their reflective plates scatter sunlight so strongly that enormous regions of the sea turn pale blue or milky turquoise. The bloom can become visible from orbit. This means that a color pattern covering hundreds of kilometers may be produced by single-celled life. Other kinds of phytoplankton create green, brown, or reddish patterns depending on their pigments, density, and the chemistry of the surrounding water. These blooms are not merely decoration. Phytoplankton form the foundation of many marine food webs. Through photosynthesis, they also participate in the exchange of carbon between the atmosphere and ocean. From space, life does not always appear as individual forests, animals, or cities. Sometimes life appears as color, a swirling blue-green signature spread across an entire sea. The Sahara helps feed the Amazon. One of the most remarkable relationships visible from space connects two environments that seem completely opposite: the Sahara Desert and the Amazon rainforest. Satellite instruments can track immense clouds of African dust traveling west across the Atlantic Ocean. A significant portion of this dust originates from ancient lake beds and mineral-rich regions of North Africa. Winds lift the particles high into the atmosphere, where they may travel thousands of kilometers. Some eventually fall over the Amazon basin. Amazonian soils are heavily weathered, and rainfall continually washes certain nutrients away. Saharan dust carries phosphorus and other minerals that help replace part of what the rainforest loses. The world's largest hot desert therefore contributes nutrients to the world's largest tropical rainforest. From the surface, these places appear entirely separate. From orbit, They are connected by a moving atmospheric bridge. The same dust can also influence cloud formation, air quality, sunlight, and ocean ecosystems during its journey. Space-based observations reveal a lesson that is easy to miss from the ground. Earth's environments are not isolated systems. A dry lake bed in Africa can affect trees in South America, air over the Caribbean, and microorganisms in the Atlantic Ocean. The planet is stitched together by invisible transportation networks made of wind, water, and dust. The planet appears to breathe. When satellite observations are compressed into time-lapse sequences, Earth's vegetation seems to pulse. During spring and summer in the northern hemisphere, plants awaken, leaves expand, and photosynthesis increases. Vast regions become greener. As plants absorb carbon dioxide, seasonal changes can also be detected in the atmosphere. When autumn and winter arrive, vegetation declines across large northern landmasses. Respiration and decomposition return more carbon dioxide to the air. Because the northern hemisphere contains more land and vegetation than the southern hemisphere, this seasonal rhythm creates a noticeable global pulse. NASA visualizations have described this cycle as watching Earth breathe. Of course, Earth does not breathe like an animal, but the comparison captures something real. The biosphere repeatedly exchanges gases with the atmosphere on a planetary scale. The movement is not visible in a single photograph. It emerges only when thousands of observations are placed together across weeks, months, and years. A still image shows continents. A time-lapse reveals metabolism. Lightning sometimes shoots towards space. Ordinary lightning usually travels within clouds or between a cloud and the ground. But above some powerful thunderstorms, a different kind of electrical event occurs. Red sprites are enormous brief flashes that appear high above storms. Some have long red tendrils and resemble glowing jellyfish. They are produced by electrical disturbances related to intense lightning far below. Sprites may extend for tens of kilometers through the upper atmosphere. Instead of directing electrical energy toward the ground, they send pulses upward toward the ionosphere. They are so brief that they were difficult to confirm scientifically for many years. Pilots had reported unusual flashes above storms, but the events vanished too quickly for careful observation. Cameras aboard the International Space Station now provide a far better viewing angle. From above, astronauts can see the bright thunderstorm beneath and the faint red event rising over it. For a fraction of a second, a storm connects the lower atmosphere with the edge of space. It is a reminder that thunderstorms are not confined beneath the clouds. Their electrical influence can reach far beyond them. Some clouds shine after the ground is dark. Near the boundary between the mesosphere and thermosphere, extremely high clouds can form. They are called noctilucent clouds, or night-shining clouds. These clouds occur far above ordinary weather clouds. Because of their altitude, sunlight can continue to illuminate them even after the lower atmosphere and the ground have entered Earth's shadow. To an observer in twilight, they may appear as glowing silver-blue ripples against a dark sky. From orbit, their unusual geometry becomes clearer. The lower planet is already dark, yet these high clouds remain in sunlight. They occupy a narrow transitional region where Earth's atmosphere fades towards space. Noctilucent clouds are usually associated with high latitudes and summer conditions. Their ice crystals form in air so thin and cold that the process is very different from familiar cloud formation near the surface. They are clouds illuminated from another time zone of sunlight, floating above night while still touching day. The night side reveals human behavior. Nighttime images of Earth are often presented as maps of cities, but not every light comes from a city. Sensitive satellite instruments can detect roads, fires, gas flares, lightning, auroras, reflected moonlight, and even groups of fishing vessels. In some seas, fleets use powerful lamps to attract squid, plankton, or fish toward the surface. From orbit, these boats can form bright clusters far from land. Without context, the lights may resemble floating cities. Artificial lighting also reveals economic patterns, transportation corridors, energy production, and changes caused by disasters or conflict. A sudden loss of light can indicate a major power outage. New light patterns can reveal construction, industrial activity, or expanding settlements. Different lighting technologies may even produce different colors in astronaut photographs. At night, human civilization becomes a nervous system of light spread across the continents. But the empty-looking ocean is not always empty. Sometimes the brightest activity is moving across the water. Earth does not look the same to every camera. Many famous images of Earth are not simple snapshots. Some are mosaics assembled from multiple satellite passes. Others use data collected at different wavelengths. Clouds may be combined from one observation, land from another, and ocean color from yet another. This does not make the images false. It means they are scientific visualizations designed to show information that one ordinary photograph could not capture. A true color image attempts to reproduce what human eyes might see. A false color image assigns visible colors to infrared or other measurements. Vegetation may appear bright red. Burned land may become dark brown. Ice, clouds, and snow can be separated more clearly. Space cameras also use exposure settings that influence what appears in the frame. This explains a common mystery. Why are stars often missing from photographs of Earth in space? The answer is usually exposure. Earth, clouds, and spacecraft surfaces are brightly illuminated by the sun. A camera exposed correctly for those bright objects may not collect enough light to reveal faint background stars. The stars are still there. The camera is simply looking at something much brighter. A space image is therefore not only a view of Earth, it is also a record of how the instrument was designed to see. The line between day and night is not really a line. The boundary separating Earth's daylight side from its night side is called the terminator. From a great distance, it can look like a sharp curve dividing the planet. But at the surface, sunrise and sunset do not happen everywhere along that boundary at exactly the same visual moment. Mountains receive light before nearby valleys. High clouds remain illuminated after the land below becomes dark. Atmospheric refraction bends sunlight, allowing us to see the sun even when it is geometrically slightly below the horizon. From orbit, the terminator reveals the three-dimensional structure of the atmosphere. Cloud tops may glow while the ground is already in shadow. Layers of haze can form colored bands. The highest atmospheric particles can remain sunlit long after ordinary clouds fade. The planet does not switch from day to night like a lamp. It passes through layers of illumination. Every sunset seen from space is not just the sun disappearing. It is Earth's atmosphere separating sunlight into altitude, color, and time. Earth's blue color is partly an atmospheric effect. Earth is known as the blue planet, mainly because oceans cover most of its surface. But the blue appearance of the planet is also influenced by the atmosphere. Small gas molecules scatter shorter wavelengths of visible light more efficiently than longer wavelengths. This Rayleigh scattering helps make the sky blue and contributes to the blue atmospheric rim seen from space. The ocean's color is more complex. Pure water absorbs longer red wavelengths more strongly, leaving more blue light available to scatter back. But real oceans also contain sediments, dissolved organic material, and microscopic life. This is why coastal water may appear green, brown, or turquoise, while deep open ocean appears dark blue. Clouds are usually the brightest large-scale feature because their water droplets and ice crystals reflect sunlight strongly across many visible wavelengths. So the planet's familiar palette, blue oceans, white clouds, brown deserts, and green vegetation, is not simply painted onto the surface. It is produced by a constantly changing interaction between sunlight, matter, atmosphere, and life. Earth's color is a process. From the ground, we experience Earth in fragments. One coastline, one storm, one city, one season, one sky. From space, those fragments become connected. We see dust leaving a desert and feeding a forest. We see microorganisms changing the color of an ocean. We see hidden waves moving beneath apparently calm water. We see mountains shaping clouds, plants changing the atmosphere, and thunderstorms sending electricity toward space. We see that the atmosphere is not an empty layer, but a glowing, moving, chemically active ocean of gas. And perhaps the most important discovery is not a single phenomenon. It is the realization that almost nothing on Earth exists alone. The oceans influence the clouds influence sunlight. Dust influences forests. Forests influence the atmosphere. The atmosphere influences every living thing beneath it. From space, Earth does not look like a collection of separate countries or isolated ecosystems. It looks like one interconnected system, complex, restless, and astonishingly fragile. A world surrounded by darkness, yet glowing with weather, chemistry, water, and life. We have photographed other planets. We have studied distant stars. We have found storms larger than Earth and worlds covered in ice. But so far, no place we know looks quite like this. A planet that glows. A planet that changes color. A planet whose oceans hide moving landscapes. A planet that appears, in its own vast and complicated way, to breathe. This is Earth from space. Not the world we think we know, but the hidden planet that has been above us, below us, and around us all along.